This is a very interesting question. Aeroplane has to go from a point A to another point B 500 km away 30 degree east of north. Wind is blowing due north at a speed of 20 meter per second. The airspeed of plane is given as 150 meter per second. So we have to go with find out two things. First is find the direction in which the pilot should head the plane to reach point B, and second is find the time taken by the plane to go from point A to point B. In this case, it is given that the plane, let us draw the first of all the direction. So this is our east and this is our north, and the plane is in 30 degree east of north. Okay, so it means this is the direction of plane. It is 30 degree east of the north. So we can say this is plane direction, and wind is flowing due north. Okay, so this is wind direction. So this is point A and this is point B. So the plane should be traveling from A to point B, and the direction of wind is this one. So it's clearly understood that this wind will be pushing the plane towards the north. So ideally it should be traveling in a direction such that the final point of its destination, which is given as B, should be there. So if we want to draw with respect to how the heading of the plane should be, so we can draw it in this way. So this is east, this is north, and this is point A, and suppose the plane should be at point B, and the wind is pushing the plane in this direction. So let us suppose the pilot makes the plane to travel in this direction, which is AC. Okay, so that the final direction comes out to be this one, that is AB. Okay, so this is 30 degree. Let us suppose this angle is theta. Okay, and we say that this is velocity of the plane VA. In that direction, this is velocity of wind. Okay, if this angle is 30 degrees, so this will be also 30 degree. So this is the basic diagram in which the plane will be flying. Okay, now it is given that velocity of the wind, okay, so we can write velocity of the wind is given as VW, and it is given as 20 meter per second. Velocity of the aeroplane is given as VA, and this is given as 150 meter per second. So first thing, we are going to find out the value of theta. So we can say that in triangle ABC, by sine law, we can find out that 20 divided by sine of theta will be equal to 150 divided by sine of 30. So from here we can find out sine of 30. Sine of 30 will be equal to 20. Sorry, sine of theta will equal to 20 into sine of 30 divided by 150, and this will be coming as 1 upon 15. From here we can say that theta will be equal to sine inverse of 1 upon 15, and this is coming approximately as 348. Okay, so the angle in which the plane should be flown will be equal to 30 plus theta, and this will be equal to 30 plus 348, and this we can write 3348. Now we can say in the direction the angle is east of north, east of north, okay, by 33 degree 48. So this is the first part. In the second part, what we do, we divide this all these components into the x and y parts. Okay, let us redraw it again. East, north, and we have this is point B, and it is given as this is 30 degree. Okay, and this is point C. We have this is VA, and angle is given as theta. Okay, so we can divide VA into two parts. First will be in this direction, that will be equal to VA sine of theta, and another one will be in this direction, that will be VA cos of theta. Next, the wind direction, we can draw the vector of wind direction here, or we can draw it here also. Okay, so this is VW, because we are only interested in dividing it into magnitudes. Okay, so in order to make it very clear, so we draw wind vector in this direction, so it can be divided into two parts. First, in this direction, so this angle will be 60 degree, so we get this as VW cos of 60, and second will be in this direction, VW sine of 60. Okay, so now we want the second part, that is time taken. We already know the distance AB. Distance AB is given as 500 km. So in case we find out the velocity, okay, so we can use the formula that time taken from A to B will be equal to distance divided by velocity. So distance we already know, we already need to find the velocity. Okay, so velocity in the direction AB there are two components, VA cos of theta and VW sin of theta. Okay, so what we did, this was VA in this direction, so we divided VA into the two components. One is VA sin of theta, that is this one, and another one in this direction, that is VA cos of theta. Wind direction, what we did, we plotted along this axis, that is in the north direction, and again divided into two parts. This angle will be 60. Okay, and we get VW cos of 60 and VW sin of 60. Okay, so you can say that velocity along, we also write velocity along AB. Okay, velocity along AB. So we put the values, velocity along AB, velocity along AB. Okay, let us call this as velocity AB, and this will be equal to summation of both the components, VA cos of theta plus VW sin 60. We put the values. Okay, so we get velocity along AB is equal to VW is given as 20, and we have sin 60, that is 3/2 plus 150, and theta we already know is 33 and 48. So we find out its value, it will be coming as 224 divided by 15. So if we solve it, this will be equal to coming as 167 meter per second. Okay, this is the velocity AB. You can see the velocity along the direction AB. So we already know that time is equal to distance oblique velocity in the direction AB. Distance is, that is AB, that is 500 kilometers. So this will be 500,000 meters, and 167. Okay, so we get this time is equal to 2994 seconds, and this time will be approximately equal to coming as 50 minutes. Time approximately will be equal to 50 minutes. So this completes, we found out the direction as well as we found out the time taken from point A to B. Okay, so we can say that time A is time taken by the flight from point A to point B. This is equal to 50 minutes. Okay, thank you.